Testing. Okay, fantastic. Well, thank you for coming in, especially on the first session immediately after the party. Not sure how much popular the other sessions are, but there's lots of other good ones, so I'm flattered you've come to this one. Let me start by introducing myself. My name is Mikio That. It's a name almost like seemingly designed to test spell check and test web validation forms. There's like little boxes where you have to put a character in each of your name and like the OCR scans it. My name is so long that you can't actually put it in, which is fantastic. I work for a company called Simply Business. We are an insurance broker, which is a fancy name for saying we're basically an insurance selling middleman. So we partner with a lot of the big insurers, and we specialize in selling small business insurance. So if you run a small shop, or you're a plumber, or you're a landlord, you can come to us. We give you a range of quotes, and you can just pick the one that's best for you. We are part of the Travelers Group, which is much bigger than us, so it's a name that's probably more familiar. And because we work with small and medium companies, we see a lot of that creativity, that innovation, those fresh ideas that you expect from small businesses. So we're very proud to say that we work with people creative enough to call their hairdresser Barbara Streisand. It's actually really, really good. These people are great. They're actually really close to the office. It's not just a gimmick. Or florists Floral and Hardy. There's actually tons of these. We've done like a TV spot, and we actually had to cut a bunch of them because it was so good. We are a UK-based company, hence the accent, but we also operate in the US, which is a fairly younger, fresher operation, so we don't have quite as exciting names to give, but we have partnered with one business. Not sure it's going to catch on. We've partnered with this up-and-coming online bookseller, and Amazon has this thing called its Marketplace A to Z guarantee. I have no idea how much the marketing person got paid for that rhyme, but they've launched something called the Amazon Insurance Accelerator, which sounds very exciting, but it's basically a place where you need to buy insurance if you're a third party. This is so if you buy products from the marketplace but aren't sold by Amazon, you still get some protection. So if you sell like a charging cable that catches fire and damages personal property, you still have to be able to pay out. So this is a hand-picked panel. There's only 3 choices, and we're one of them. We're actually the best one because we give you the most choices. So if you sell everything on Amazon Marketplace as a side gig, we recommend you buy from us. We're a certified B Corp, which means we care about things other than just making money, which is a novelty to anyone who hears that I work for a financial technology company. So we have to meet certain levels of like ethical governance and worker involvement. In the UK, there's this competition where they assess all this stuff and see who's the best company to work for, and we won twice in a row in 2015 and 2016. The only reason why we haven't won since is because we stopped entering, because we thought we'll give other people a go. So basically, we try to be nice people. I am a DevOps engineer, which is a job title they made up to disguise the fact I spend most of my time writing YAML. And I am part of the Platform Engineering and Services team, which is a backronym I made. And we have, our team we make a pass on top of AWS. If any of you went to the talk by, who is it? Is it WasteScript? Those, the kind of developer platform sort of thing. We try and do something similar, offer kind of Heroku-like turnkey experience. You just push your container. We handle things like domain registration, SSL, load balancing, backups, that sort of thing. We're quite a small company, so we also absorb some of the functions of like a typical SRE team. And we've got a decent amount of DBAs and people who know Perl, so we take some of the operational work as well. Now that I've introduced myself in the company, and now this is being recorded, I know legal is going to shout at me if I don't do this bit. I need to do the standard disclaimer that the opinions expressed in this talk are strictly personal, not those of my company, Simply Business, blah, 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 whatever. This is an important disclaimer, I think, because there will be some, technically controversial views expressed. So I'm slightly nervous it's going out, but whatever. I don't want you to take any of this stuff as gospel, even though I sincerely believe a lot of this stuff, but some of the stuff I'm going to discuss is stuff I think most people don't really think about or question. So if you have your own opinions, that's fantastic. At least it means that we're thinking about it. So first we need to start with a little bit of history. This is the bit that I'm going to edit out if it goes into YouTube because we'll get a content takedown notice otherwise. So with a little bit of background, I need to tell you how we ended up in a bit of an observability hole. So we are primarily a Rails house. We have a Rails monolith called Chopin. It's named after the Polish composer. We called it Chopin because someone really liked Chopin, and there were a bunch of people who didn't know how to pronounce his name, and apparently it sounds a lot like shopping if you say it badly. So that was a really, really good name for the application that handles the e-commerce side of things. And this was a true monolith. It did absolutely everything. It did quoting, which is where you plug in what you want to be insured for. It does a lot of black magic, which is actually proprietary and we can't leak. And it gives you a number saying this is how much your premium is. That's super confidential information. But it also did stuff like PDF generation. After you buy the policy, you want a piece of paperwork saying this is what you bought, this is what you're covered for, and we programmatically generate those and send them out to people after they've bought the policy. And this monolith did absolutely everything. And as is the case with the Rails monolith, it's great until it stops scaling. You're responsible for, say, the PDF generation service. You change 4 lines of code. Now you have to deploy 10,000 other lines of code you haven't changed in 6 months. You still have to run the unit tests, even though you know they're going to work. And because everyone is hacking on the same thing, the build queue gets massive, and it takes ages to deploy anything. So we did what everyone else would do and started hiving off little bits into microservices. And we ended up with what we now jokingly call the solar system model, because there's still one big, really important thing in the middle that everything kind of revolves around. But there's other substantial, sizable things that also exist, some of which are big enough that they have their own little dependencies as well. Yes. And one thing that anyone will tell you after you break apart a monolith is that even the simplest stuff now becomes a real pain to debug. The simplest GET request now goes through half a dozen applications written by half a dozen teams, in different languages. When they use the same language, they don't use the same version of the language. And before, when you look in the monolith, you can open one log file and see a request end to end. And now, when you distribute all this stuff, it's so much harder to debug. Now, we knew this before we went into it, but I naively thought we would do better, not just because I'm self-confident, but because we had what I thought was a fairly good observability stack. We read a lot of books and reports. We went to a lot of conferences about people who already did this, so we wouldn't fall in the same trap. I read all these Gartner reports, and we bought all our products on the front page of Hacker News, so that's how you know it's cutting edge. And we spend a lot of money on this stuff. We're a small company, but the company and the management were willing to invest a lot of money doing this. So I thought, okay, we're going to do this properly, and even though we're going to break apart a monolith, we're still going to have good observability. This didn't turn out to be true. We still had developers telling us that despite spending hundreds of thousands on observability tools, they had no idea what was going on. Might have been because our stack looked a bit like this. So we start with centralized logging. So logging is probably the first thing of metrics, logs, and traces that you add. Even when you're just doing a spike or a proof of concept, you're still going to put echo or print. You're going to echo out a variable just to make sure it's not empty, that sort of thing. We don't want developers just logging into production boxes because that makes security people nervous that you might have tampered with stuff. So we're going to say, you can't do that. You're going to ship your logs to a central place, and that's where you're going to look for all your logs. We looked around for what other people do for this. We found that a lot of people use Elasticsearch. We have a bunch of people who know how to manage Elasticsearch, so let's use an ELK cluster. And because we don't want to maintain this stuff ourselves, we'll go for hosted Elastic. Right, so we got our logs. We also want to be alerted when things go down, API endpoints, website, that sort of thing. Now, the Elasticsearch cluster can do this. It has synthetics, but the Elasticsearch cluster is in one region. You don't really want to spin up an Elasticsearch cluster for every region you want to send probes from. You really want just a small, cheap, dumb box that just does curl-i and then reads the response code. So we looked at what people use for this, and they say use pingdom. So we'll do that. This is before they got bought out by SolarWinds. So now we know when stuff goes down, and now we have logs. But sometimes you have problems that don't bring down the site, but are still problems, like certain assets don't load, or stuff loads, but it's really slow. So we need APM, we need real user monitoring. We're a Ruby house, so we look for a mature APM tool that has a really good Ruby SDK. So of course, we use New Relic. I haven't redone these slides since they rebranded. So, okay, now we've got application metrics as well. Sometimes there are going to be failure cases where we can foresee the failure cases in advance. And because we're responsible application developers, we do exception handling. We don't just blow up. So, you handle the exception, throw some useful information into the logs, but you don't just want to throw stuff in the logs, because then otherwise you'll never find that exception again. It would be nice if you could surface those exceptions into some kind of inbox. So we decided to pick this tool, which kind of looks like if McDonald's made an observability tool. That thing is Airbrake. It pitches itself as like an APM suite, but effectively we use it as an exceptions inbox. You instrument your application. When you throw an exception, you wrap it inside this Airbrake library, and it posts some context about what library it was and what time it was, and collects and scrapes some metrics about the host that threw it, so you have some context. So that's all the application stuff done, but obviously sometimes it's not the application, sometimes it's the infrastructure. So we asked sysadmin people, what do you want from an infrastructure monitoring tool? They say this thing called Datadog is good, so we add that. Now this is being recorded. I'm totally not going to get invited to the Datadog conference, but that's fine. Vegas is nice. So now we've got all the key stuff. We've got the infrastructure metrics, we've got the application metrics, we've got the synthetics, we've got the exceptions, we've got the centralized logging, we've got everything that everyone says we should have. But now these things are all in a bunch of silos, so it would be really nice if you could all put this stuff in one place. So when you're debugging stuff, you can put your links and everything in one place and have a process around it. So of course, process means you add Jira. I mean, to be honest, this probably is where things start to go wrong. Because, okay, Jira's got all this integration because everything integrates with Jira, but now you have to write all this integration, and we have Slack, and the alerts go to Slack, so you need the webhooks, and you need to generate the secrets and the API keys, and now we're writing a bunch of extra glue code, and we're adding extra complexity just to manage the existing complexity. But when we did this, we called these abstractions, which didn't sound as bad as tech debt. And everyone I know was doing something similar. So I was like, okay, this is fine. This is just normal. And these tools are legitimately, these are some of the best tools in each category. So we're like, well, we can't be doing worse than any others. And so this is kind of what it looked like in reality. I'm not sure if you can see at the top there with the Lamb of God and the rainbow and the halo and the book of stable APIs. That's observability as we saw in my fantasy. Right, and then in reality, each of these things has its own slightly different SQL-like, but not quite SQL language. Kibana used to have Lucene syntax, because it's built on top of Lucene, but then they thought we don't want to do that, so we're going to make our own query language called the Kibana query language, or KQL. You need to know NRQL, obviously. If you want to use the NerdGraph API, you need to know GraphQL. There's also, PromQL, DodeQL, can't believe it's not QL. Which means you can't query your JavaScript errors using the same syntax that you would your infrastructure metrics. And there's no real good reason for that, apart from the fact they happen to be in different tools. And the way the licensing for some of this stuff works, it doesn't get cheaper if you just don't use half the features of New Relic, right? You just don't use half the things you pay for. So things like the synthetics, we were on a New Relic's plan that had 1 million free synthetics, but we decided, no, we don't use New Relic for synthetics, we use Pingdom. So we're just paying for a bunch of stuff we didn't use. We realized that our observability budget was close to getting up to $1 million a year. That doesn't sound as bad until you realize we've only just crossed 1,000 employees. That's total, not just engineering. We are not a very big company. $1 million just on an observability stack is not really normal. So we decided we need to do something about this. So we're going to do that thing that strikes terror into the hearts of all developers. We're going to do a migration. So we found that most of our data is in Datadog, it's in New Relic, and it's in Elk. And we found that a lot of our problems is because you have to have multiple tabs open just to correlate simple things. You want to match up CPU spike to elevated error rates. So you snap one tab to the other, and you set your time range, and you hope they kind of line up. For once, we're going to put everything in the same place. And spoilers, we pick New Relic. which is why I'm here and not at the Datadog conference. It's okay, they're paying for my hotel. I'm happy to do this again if need be. And so we're going to put everything into New Relic. We're going to move all our synthetics. We do infrastructure monitoring. We even do on-prem infrastructure monitoring, so we can, our internal IT systems team actually proactively monitor people's remote work from home connections. So they can be things like, we've noticed that like your VPN connection seems to be really, really flaky, and we can help debug that. So we're hoping that, I mean, we're not expecting it to be perfect, right? It's not supposed to be the promised land. Like, this is Dante's paradise, but like the point still stands. We just want it to be better. We're expecting just like single pane of glass. You go to one place to look at all your things, one interface, one API, not having to be an expert in half a dozen query languages, not having to juggle multiple Terraform modules to provision dashboards that could just live side by side. That's the dream. And obviously people hate migrations. The best thing you can say about migration is stop all your feature work, throw out your roadmap, and after all this work, the best you can say is you can do the exact same thing that you were doing before, just somewhere else. So as a platform team, our goal is to actually try and remove a lot of this application code changes and this heavy lifting. So stuff like system metrics, infrastructure stuff, that's actually really easy to move. You can just throw out the Datadog agent, put New Relic agent in. If you're not migrating New Relic, you can put whatever you want here. Most people would instrument that stuff out of the box. Logs, hopefully you're using a log forwarder of some sort, like things like the OpenTelemetry log collector, or in our case, Logstash, means you have one central place where you can normalize some of this data, so we can easily send it to any other backend. That's fine. DogStatsD, a little bit of a hot mess because it's kind of a proprietary extension, but it is a strict superset of statsd. So you can actually just strip out all the DogStatsD stuff. You don't have to actually, you can continue to use the DogStatsD library, but you could just use any vanilla statsd forwarder and it will just ignore the Datadog specific extensions. So all of that stuff is fairly portable. What you need to worry about is stuff where there's no real kind of open standard for. Like there's no like industry standard on how to define in JSON what a dashboard is. There is no way around it. You're going to actually have to ask people to recreate those from scratch. And the least painful way we found was actually to create an abstraction. So in our case, Terraform modules. A lot of developers don't know Terraform as well. It tends to be an infrastructure-y kind of thing. So what we did is we created Terraform modules that already gave you sort of sane defaults that would already write the NRQL query. All you had to do was plug in your variables. So it's like, drop this module into your application. Our pass already handles running arbitrary Terraform. And you just write a config file that has Terraform variables. Say, I want to alert when CPU is above, 95 for 5 minutes. And when it does, send an email to this and this Slack channel. And that's all they need to know. And they can just treat it as just like any other external dependency. We update it for them, and they don't need to worry about it. And this mostly works. There's a lot of talks, I've noticed, about tool fragmentation, the benefits of consolidation. They'll probably all say stuff like this, faster onboarding of developers because you need to know fewer tools, transferable experience, even if you go into a new kind of application that you've never looked at before, because it's instrumented in the same way, you feel more confident digging into things because it's like, well, I don't know this application well, but I know how to know more about it. Faster adoption of new features because you only really have to support one thing. The logs thing, this is just a general when New Relic logs are amazing. I won't get into this too much because I know Sacha from Footlocker did a talk almost exclusively about logging, and he did it much better than I do, so hopefully that's been recorded. And some features just become much more attractive when they're paired with other features. So things like distributed tracing, we really struggled to sell this benefit to people because they're like, oh, okay, that looks like a cool Gantt chart-like thing. But it's not enough to resolve problems by themselves. When you have stuff like logs in context, then it becomes useful. Yes, we had this data before, but just having that convenience factor can really, really be a big win. But that's obviously not what this talk is about, which is all the stuff that went well. I'm nervous because this is about all the stuff that went horribly wrong. All the stuff that would have been really nice if people had told me beforehand, because this has been 16 months of my life now. I feel like I've become like a New Relic man at my company. So this stuff is stuff I learned as a result of the migration. You don't have to yourself be doing a migration to benefit from some of this stuff. So regardless of whether or not you're doing a migration, these are some of the anti-patterns that I found, and it's too late for me, but you can save yourself. All right, let's get going. I did warn you about controversial opinions, so hence the HTML tag. Right. Controversial opinion number 1, despite what you've been told, observability is not a fancy name for metrics, logs, and traces. This is a diagram, or a form of this diagram should be familiar to most of you. This is supposed to be the 3 pillars of observability. I know the pillars are really wide, but otherwise I couldn't put the text in. So this is something that you'll see repeatedly in multiple blog posts and O'Reilly books and people's Medium posts, and they think they're being original. And this whole idea is that observability is a thing that's held up by 3 pillars: dimensional metrics, logs, and distributed tracing. Now, I have much beef with this metaphor, partly because it's not true, and also because it's constantly repeated. So metaphors like this, they're good if the thing you're comparing them to really have some similarities. So this is a good metaphor if these are really like pillars. And what is the function of a pillar? Like, assuming these are load-bearing pillars and not like decorative ones that make things look neoclassical and expensive, the whole point of a pillar is that they hold things up, right? They're supporting. And you can't just take pillars out because then stuff falls down. Even if you leave them, you can't like neglect them and like half-ass them because then they also kind of break down. And you can't build them on rocky or non-solid foundations because then everything comes crashing down. If this is 3 pillars, that means these are necessary for observability. You need to do all 3 and you need to do them properly. And the problem with this is it kind of like treats observability like it's like a perk in Skyrim. Like you spend your perk points or your IT budget or your story points implementing metrics, logs, and traces. And then congratulations, you've now got sufficient observability that you can unlock this 4th thing, because it is a 4th thing, right? It's not like a circle around these things. You unlock some capability that is just more than metrics, logs, and traces. You get something more than the sum of its parts. That's the promise. And what you find is actually, the reason why I'm kind of salty about this is because I really believe that stuff, and it influenced the way we approached observability. When our developer said, we don't know what's going on, I'll be like, well, I looked at this, and it says, well, if you haven't got observability, it's because we don't have these prerequisites, right? We must be doing something wrong. So we put more custom metrics. We have a big talk about how to do log schemas and have human-friendly logs. We're going to put distributed tracing on absolutely everything. And if we do enough of this, then we'll get observability. That's not what happens. What you do if you collect more metrics, logs, and traces is you just get more metrics, logs, and traces. You're not guaranteed to get better observability. And this is something that like certain like vendors like to sell. I call it the attitude like spray-on observability. Like you buy this like product already, you just include it to your application regardless of how it's architectured and like what your business practice is, and somehow magically you have some insight into your application. That's usually not how it works, right? And there's loads of these analogies. They're all terrible. I mean, this is a slide from otherwise really good talk at Splunk. I don't understand this line because there's no y-axis, so like you don't know if higher is better and like what's the number? Is it logarithmic? I have no idea. But they say the difference is metrics help you detect problems. Traces tell you where the problem is, and the logs will tell you what the root cause is, and presumably you flow from left to right. And this is a nice, clean definition of when to use what. It's just a shame then that it's not true, right? Because you can not have metrics and detect problems, right? Like you can just have logs and you can say, I know, select count from log where log level is fatal or error and then raise an alert. And that works, right? Nor is the sole function of metrics are to detect problems, right? There are other, like, these are just different data types. And yes, you can use these for these functions, but that's not what their definition is, right? And this is true of all of these kind of attempts to like define them in a nice, clean way. This is Honeycomb. They make a really nice product. They say, oh, they're not pillars, they're lenses, which doesn't make anything. They say it's like, oh, if you like, they give you like, they highlight certain things and like, so the metrics might highlight some things and hide certain things, but if you have all three, you get a full picture. If you only do one, yeah, you can see the sunflowers, but they look weird. But the problem all of these analogies make is that they think metrics, logs, and traces are what observability is about, and it's not. Like, observability is just the ability to look at a system and say, I understand what's going on, right? And these are just ways that you might get more information about it. But observability is not a state of a system, it's the state of the person looking at the system, right? You can have metrics, logs, and traces. That doesn't mean you have observability. Likewise, you can have one or two of them and still have a perfectly good understanding of your application and its system. So don't get fixated about thinking that it's about telemetry data and that if you just have enough of it, you'll be fine. What it really is about is developers being able to look at something and say, yeah, I know what's going on. I thought this was going to be the most controversial one. Hot take number 2, you're probably freaking out about vendor lock-in too much. Worrying about, one of the reasons why we had that hot mess of a stack for so long is we thought, well, it's an insurance against vendor lock-in, right? If we go all in on one platform, they can hike our prices and we're probably not going to move because it's going to be such a pain, especially if we integrate with like new Relic-specific features or Datadog-specific features that we're not going to replicate. They know that. They can turn the screws on us. And this is an attitude that you also see with like cloud providers, right? So you see people go, we're going to go multi-cloud, not because they need to go multi-cloud, but as like a hedge, as an insurance. So but what happens then is you just build to the lowest common denominator, which is usually really, really low. And as a result, you don't really take advantage of all the features that you get in each specific cloud provider. And I see this as something that especially engineers seem to be prone to, more so than like business people, which is interesting because it's usually like the business person's choice to spend this money. They have this visceral hatred of anything that looks like proprietary or specific to a vendor because it's lock-in and like it's a trap, and like then like when you move it's going to be horrendously painful. But then you ask them like, are we going to move, and if so, when, and how much is it going to cost? And it's like, well, we might move or we might not. It could be in 6 months, it could be in 10 years. In 10 years, the business might not be here, the environment will have changed, people don't know how much the thing costs. So you're doing a cost-benefit analysis, but you don't really know what the future cost is going to be. And this gives me particular frustration because I think as engineers, I expect us to do better on this. Like, we know things like Yagni, right? Like, you ain't gonna need it. You don't write the feature just because you think someone might ask for it in the future. You wait till someone says, I need this, then you build it. You say, like, premature optimization is the root of all evil. Look, I've made this script run 20% faster. It now finishes in, 40 minutes. And it's like, that's great, but the customer doesn't care so long as it works overnight. But we don't apply the same kind of thinking to our developer observability services and practices. We think it's just like, oh, we're just worried about this thing that might happen in the future that we don't know how expensive it is. So as a result, it's worth incurring a real cost now. So the flip side of this is if you hedge against vendor lock-in, you're probably sacrificing your developer experience in some way. And that is something you should probably worry more about. People would tend to follow the path of least resistance, not because they're stupid or not because they're stubborn, but because most of the time that's what makes sense. We had teams that were mostly comfortable with Datadog because that's where their data was, or because they used Datadog in a previous company. And so when something went wrong, their first instinctive reaction was to open Datadog. They have no idea whether or not the data they need to debug that problem is actually in Datadog, right? It could be an infrastructure problem, in which case, fine, but it could be an APM problem, in which case you should have opened New Relic. But they'll just instinctively go for what is familiar. We had people comfortable with New Relic who would open New Relic and then look for problems that they could solve with the tool, not the problem that they actually had. And I confess that I did actually used to blame developers for this. I was like, look, we spend all this money on tools, we spend all this money on training, we've given you best-in-class tools, why don't you use the best tool for the job? But really, it's less like these developers are stubborn and they only want to use hammers because they really love hammers. It's because the hammer is right here, and like, okay, it's a screw, and technically you should unscrew it rather than pulling it out like a nail, but the screwdriver is in like another cabinet on the other side of the building, and obviously it's locked because it's a different, it's a different service, you need to request permission for it. You get your screwdrivers, you open them up, and it's only Phillips screwdrivers because the Torx is a specialized tool that's in another building. And by the time you do all of that, you might as well actually try and use the wrong tool for the job. You might as well try and pull the screw out with the hammer, because it might actually be quicker and easier. I mean, we're laughing at this, right? But for all we know, he doesn't have a vacuum cleaner, he doesn't have like a broom, this is all he has, so can we blame him? And I think it's because like developer experience is usually sold as this kind of really fuzzy thing. You have to say like, oh, like, we want to make developers happy because we care about them. Like, happy developer is a productive developer. And it's really hard to quantify this benefit to people. You have to just say that, oh, they'll be more productive. Look at this McKinsey report, right? Whereas the cost is real. Like it's much more visceral if you go to a senior business person. But developers are really, really expensive. And just because wasted developer time is not something that comes up on like an account sheet doesn't make that cost any less real. This is my final point. Controversial opinion number 3, you should only use logs to debug your applications. This sounds really obvious, right? And yet in a couple of slides it might not be. So there is this really good book/report called Distributed Systems Observability. You can actually find this just online. This particular chapter is completely free to read. Paste this into Google, and it's actually a really, really good book. It tends to cover more things about like the theory and the practice of observability rather than specific tools, so it's actually aged really, really well. But it has this quote that I want to read in my best BBC voice. Event data isn't used exclusively for application performance and debugging use cases. It also forms the source of all analytics data. This data is often of tremendous utility from a business intelligence perspective. The interesting aspect here is that there are striking similarities between questions a business might want answered and questions software engineers and SREs might want answered during debugging. The suggestion being that, okay, you've got all these logs that you collect because your devs and your SREs need to debug their applications, but these are reflections of events, and it's not just engineers who care about that stuff. Business analytics people do, sales people do, the manager does. So why not make your logs go farther and actually use those to answer business intelligence questions? And they say there's striking similarities between these questions, to which I say, yes, they're strikingly similar in the same way that like, this baking fail has some similarities to the reference and it's striking. But just because you want similar questions answered doesn't mean you want the data presented in the same way. For one example, like imagine probably a business intelligence analyst or maybe a CTO might care about, say, Postgres database writes failing. They probably care about that because they know that you've got like an SLO, and if it's got a customer impact, they've got to tell someone or they've got to pay out damages. Meanwhile, the engineer really wants to care about hopefully getting a stack trace, and is it like a network issue? Is it an auth issue? It's the same event, but the detail you want is going to be different. Yes, you can use logs as like a stream processing platform, as just like a general database of events to answer any question, but just don't, really just don't. Like, it does work, but it's just a horrible trap. The problem with this is that, in this case, the business intelligence person doesn't really care about the event. I mean, they care about the event, they don't care about the log about the event, right? It's like, event X happens, and I care about event X. When event X happens, log happens. So if I count the logs, I can count the amount of times the event happens. So using the logs as a proxy for the event. And yes, that will work, but it's a bit like, it's getting things the other way around. It's like trying to count the number of candies you've eaten by counting the number of empty wrappers. Like, yes, it works, but because we're in the new Relic conference, if you care about events, just use custom events. We actually used to do this, and we were basically scraping logs with regexes to count how often certain events happen. The problem being that regexes are brittle. Logs are usually owned by the people who write the application. They are going to write it in a format that makes sense for them. So quite frequently, people would just change the log message to something more human-friendly. And as a result, the regex breaks, and then like all the business metrics now make no sense because the regex doesn't match. It's much easier just to have a custom event, and if you want to care about how often a thing happened, you can just do select count from some metric or some event, and that's a much more stable interface for them. I belabor this point because logs are usually the first thing that you include. So it's going to be the stuff that people are most comfortable dealing with, and if you apply this same attitude to events, you're going to end up down a slippery slope, because you can't just stop at events. I mean, if logs are just event data and you have them anyway, I mean, well, you can replace metrics, right? You can just get rid of dimensional metrics entirely. Like, who cares about like CPU and RAM? You can use logs for that, right? Let me give you a real world case. In one case, we wanted to know about how often we were publishing events to Kafka, right? So we need an events per second rate of how often we publish messages. Now, an obvious thing would be you have a custom metric that just increments a counter monotonically, because that would be lightweight and that would make sense. But we've got logs, right? Because we did that when we developed it. So we could do select count from logs where message like sending event. And hey, look, we've got how many events we've sent. And I can get a rate out of this. I could wrap the entire thing around a rate and put comma 1 second. And hey, I've got events per second now. We actually still do this in some places. It's a really pernicious pattern because it's so easy to get started with. You don't need to change your application code in any way. If the data's just there, people are just going to use it rather than asking a team to actually instrument things. But as a result, it's like that equivalent of like Japanese knotweed that once you include into your yard, you can't get rid of it because it spreads quicker than you can remove it. It's so much easier to just not fall down this trap. Because we wouldn't accept this in our application code, right? We wouldn't treat our application data in the same way. If I wanted to print my name in Ruby, I could start with a hash, right? Whose keys are the one index position of the characters in my name, and the values are the letters. I can take the values, make an array out of them, and then join that array and make a string, and that would work, right? But no one would say this is more sane than just instantiating a string. It makes much more sense just to present the data close to the format in which it's needed instead of doing type gymnastics. But we will treat our telemetry data in these strange ways where we'll abuse conversions and bend things to try, and they will work, but we don't really apply the same rigor to our telemetry data as we would data in our applications. So if there's anything that I want you to take away from here, I feel like the main theme is, we are all good engineers, I hope. And so, we know about what are good practices, common anti-patterns, Yagni, you ain't gonna need a premature optimization is the root of all evil. And yet we don't seem to apply this stuff when it comes to observability. We kind of stop when it comes to applications. Ease of use is more important than technical superiority. Because we're engineers, we like the idea that the technically best solution is the solution that's right. It's not always the case, right? I mean, most of us here are probably primarily web developers, I assume, or we use web technologies most of the time. We don't pick the web because it's got the best access to low-level hardware, or it's got the best native look and feel, or the best power efficiency. You pick it because that's the easiest deployment target, because you can reach a big audience and people understand how web apps work and they don't have to install this weird framework to run things. We do it even though it's inferior in most ways because the tool that people will actually use is worth more than the thing that is technically nice but most people are intimidated by. Sane formats is more important than the fear of repeating yourself. Ingest is comparatively cheap compared to the amount of time you'll have to spend grooming your NRQL to get data in the format you want it. If you're constantly doing those formats, just save it in that format. It's fine. Duplication is okay in that sense. And secondly, I feel we underappreciate developer time. Developer time is one of the most expensive things in the world, alongside Saffron and HP printer ink and AWS egress charges. On this link, I initially put Bitcoin, but I wrote this about a month ago, so that's not really true anymore. It's still, relative, compare with 1 month ago. When you're paying dozens, hundreds, or thousands of developers 6-figure salaries, 10 minutes of wasted time is really expensive. Right? And if you build that, it's totally worth, investing this money in order to make their lives better. It's not just, I'm not doing this as this kind of fuzzy-duddy, oh, like, we care about developers, so we want to make them happy. Even if you were like a crass, like Dickensian capitalist, this is the most efficient use of your resources. And I think because, we're engineers, that I hope that, there's a lot of books about how to do software development well. Right? There's stuff like Pragmatic Programmer, and there's projects like Agile has come up. All this stuff about how do we do software development well. And so when you learn stuff, we all internalize the stuff. But telemetry data has not really been a developer responsibility for as long. So we don't really have this wealth of knowledge and all these idioms that we can fall back on. But a lot of the stuff still remains the same. Like the data is the data. Just because it's telemetry data, not application data, doesn't mean that you should do strange things to it or abuse it in ways that don't work. So I hope some of this stuff might come across as novel, but also in a way not. We already know some of this stuff. We just need to apply it to telemetry data. And if we treat it as a first-class citizen, I think we'd all end up in a better place. You've all been a lovely audience, hearing to me basically rant for 45 minutes without interrupting. So I'll finally shut up. Thank you.